So this is the last series of videos which is devoted to classes for block number 4. And similar to the previous videos, I will simply take several cases and show how to solve them. And these cases will be very much like what you will have in the mini project. Okay. So my goal is, first of all, I will take a big case for qualitative data analysis and analyze it in all details. And then I will also take a couple of smaller problems for the non-parametric statistics, similar to what I had before. So for the qualitative data analysis, I'm going to use a data set I actually acquired last year. I asked all students who actually took this course last year to answer some questionnaires. You can see the questionnaire here, and you can see that I got 91 response. Okay, so the questions were purely qualitative. First of all, I asked it to select which car is better, Ferrari or Volvo, or which one of these two students prefer. Then Messi or Ronaldo, it's football players, famous football players if you don't know this. What do you drink usually for Friday evening? Champagne, beer, juice, or soda. And then what's your next summer holiday will be in Italy or Iceland. Okay. Of course, it's a funny data. It's not the real research. It's just to use something real, not just simulated data. Okay. And then I got 91 responses, as I told you. And then actually you can see that I used Google Forms to carry out the survey. And then you can see that Google Forms already give me some statistics. It uses this worst chart ever, the pie charts, but we just need the data. Okay. So luckily Google Forms, they also allow me to download the data as an Excel sheet. So I just open it. So you can see that every row is a reply. So this is a particular student. It's anonymized, of course. So what I see here, it's a time. You can see it's 10:35. It's exactly was the beginning of my lecture at 10:30. And then the answers. For example, the first student answered Ferrari, Messi, Champagne, and Italy. Okay. So this is a typical qualitative data with 91 values and 4 variables, 4 factors, 4 qualitative variables. And that's what I'm going to analyze in this video and also in a couple of next videos. So first of all, I need to download this data. I download it as an Excel sheet, and then I need to copy it to my R folder. Now I switch to R, and then you can see that's the Excel file I got, B4 survey responses XLSX. Okay. Now first of all, I need to load this data. So I will make a new script for that and call it B4. And I think I forgot to make it as a working directory, so I'll set it as working directory and save it as B4.04. Let's say seminar 1. Let's say lecture. Okay. So that's the script, and then first of all I need to load the data. So I say library read Excel, and then D read Excel, and then this. Let me just run this first, and then I will just use this to avoid writing and making mistakes, typos, and so on. I will simply do it like this. And then that's one important thing that some of you had issues with. This function read Excel, it returns a special format that's called table. So let me remove this first and then run it. Okay. So what you see, it looks like a data frame, but it's not. If I write, for example, head D, so if I want to show only first several values, you can see it looks a little bit varied. And then it's written, it's table. Table is a special format, which is like a data frame on steroids. But we don't need any steroids. We need a pure data frame. So therefore, you need to add a line here. You say as data frame D. So it means take this table and convert to data frame. And we know data frames very well. We know how to work with them. So if you don't know how to work with tables, always use this as data frame D after you read your Excel file using this read Excel. And that will actually remove most of the problems you have. Okay, now if I run it, you can see if I say head D, now I don't see all this varied information anymore. I have only the values, right? If I open it though, you can see that timestamp, it's a special format. It's a time and date format. So we don't need it actually. But the other variables, you can see that they are characters. So we need to make them factors, right? And also they are pretty long. Okay. Let me select two variables for the further consideration. So let me say cars, and then I say S factor, D dollar, this Ferrari or Volvo. Okay, so if I run it, you can see I got cars as a separate vector. It's not a part of data frame anymore. It's a separate vector. Now it's a factor because I say S factor here, right? You can see it's a factor with two levels. And then let me take one of the variables where I have more than two levels. It will be the drinks, right? So I say drinks, S factor, D dollar, what do you drink? What drink you will choose for Friday evening, right? So this is drinks. Now you can see it's three levels, okay? So that's my data set, cars and drinks. And my scientific hypothesis is that, let's say that people who let's say, drive Volvo, they prefer champagne or no alcohol at all. And people who drive Ferrari, they prefer beer. So that's my scientific hypothesis. So cars, I mean, I would say Ferrari, it means beer. Volvo means champagne or no alcohol. Champagne or no alcohol. Okay, of course, I mean, there is nothing scientific behind it. It's just to show you how it works, right? But the null hypothesis in this case, of course, it means, I mean, it's the opposite. It means no effect, right? So the null hypothesis, no association between cars and drinks. By default, I assume there is no association between these two variables, but scientifically, I think there should be association. That's the reason I actually make this experiment. Okay, so this is it. Now we have the data, now we have everything, and let's start doing the analysis. Well, the first step, and it's always, it's not only for qualitative data, it's for all data ever. First of all, visualize your data. Use proper plots to visualize your data, okay? In this case, I cannot just visualize cars and drinks because it's factors, it's not actually numeric values. So therefore, I need to make a summary. I need to summarize it. And we know that we can summarize qualitative data using frequencies. So we just need to count how many people would like to drive Ferrari, how many people would like to drive, drink beer or champagne, and so on and so forth. Because I have two variables together, so let me make it also together. So let me combine these two variables by using function table. So cars and drinks. And then I'll show the table. Yeah? So you can see that that's interesting, right? So you can see that, for example, if we take beer, 25 people who prefer Ferraris, they also select beer. And 23 people who prefer Volvo, they select beer. So you can see we have a little bit more for Ferrari. Is it significant or not? We will find out later. The funny thing is that the people who prefer Ferrari also prefer champagne, 13/4. So maybe my hypothesis should be opposite, right? So it's actually when you drive Ferrari, you prefer champagne. And then you can see juice or soda, it's 15/11. So again, it's a bit difficult to say. First of all, it's difficult to say because we see counts. Of course, in our data, the more people prefer Ferrari over Volvo, right? So let me summarize this, okay? So let me add a couple of things to this table. So first of all, let's say frequency cars, and in this case, I simply take a sum of every row, right? So to get this frequency cars, I take a sum of every row. I say row sums T, yeah? And then let me show it as well, F cars, yeah? So you can see that it gives me an overall overview what's going on with cars. You can see 53 out of 91 prefer Ferrari and 38 prefer Volvo. Okay, I can of course visualize it by bar plot, F cars, and then you can see this is the bar plot. So you can see this is Ferrari, this is Volvo. If I want, I can make it in percent, right? So I can just divide to sum of the F cars, so it will be a total sum of responses. And then you can see this scale is percent. Of course, you can change colors and so on, but that's I'll skip that because you know this very well already. Yeah. So this is a plot for cars. So you can see that people in general prefer Ferrari over Volvo. Well, that's sort of expected, right? I mean, Volvo usually is considered for middle-aged people, and Ferrari is more cool. So young people prefer probably Ferrari, although cannot afford it. Now the same about the drinks, right? So now I have drinks, the frequency for drinks. Let me be consistent and use equal sign as well. Of course, there is no difference, but just to make it consistent. So now I call sum. So I take a sum of every column. Then I can also show the frequency for drinks. I have drinks. So you can see that actually most of the people, again, it's expected, right? Prefer beer, 48, and then only 17 champagne. And many people actually don't drink alcohol at all on Friday. That's really cool. So let me show you the F drinks again. First of all, the real values. So you can see that F drinks. So you can see that we can clearly see that the beer is almost twice larger than the other two. Right? And then I can also take it, divide it to sum of the drinks, of the responses, of course, drinks, like this. And then you will see this more than 50% prefer beer, about 20% prefer champagne, and then the juice or soda, it's about 30%. Right? So that's how it works. And also you can make a plot where you show the two variables together. This is how to do that. You simply make a bar plot for the whole table. Yeah. So this is how it looks like. And then you can see it's staggered. And staggered plot is actually bad. So what you see here, it's the total number of response, and then beer and then Ferrari and Volvo who prefer beer, total number of response, and then again it's a Ferrari and Volvo, and then again Ferrari and Volvo. And then if you want to avoid this staggered, you should say bar plot beside equal to true. It means that instead of stacking the bars, R will show them beside each other. So that now we can see that, okay, so this is the number of people who prefer beer and drive Ferrari. Not drive, of course, prefer Ferrari, would like to have Ferrari. Then this is the number of people who prefer beer and want to drive Volvo. Then the same you can see for champagne and then for soda. Okay, so at least I think that for champagne, perhaps it will be a significant difference. We will find this out soon. Okay. So you can also, of course, make pie chart. I will not show you that because, you know, the pie chart is not very good plot, but of course you can do it. This is the how to make an overview of your data and how to visualize qualitative data graphically using the simplest graphs ever. It's a bar chart.